Welcome to my Kcse revision channel, Teacher James Marita. We are looking at Kcse past questions, and that is differentiation. And today we are looking at Kcse, a question that was set in Kcse 2019, section P, and I think paper 1. So in that question of Kcse 2019, it was a question of 2 parts. That's Roman 1 and 2. Part 8 was Roman 1 and 2, whereby we are supposed to find the stationary point of the curve. Finding the stationary point of the curve, you need to understand 3 things. 1, you get the gradient function of the curve, that is, you differentiate dy dx. After that one now, you will form a quadratic equation. In this quadratic equation, there are 3 formulas of solving a quadratic equation. You either use a complete square method, or you can use the quadratic formula, or you can use the Kcse formula, that is the product, sum, and the factor method. So after that one now, after getting the 2 values of x, you substitute in the original equation of the curve, it will give you the turning points of the curve. Then in Roman 2 of part A, we are supposed to get the nature of the turning points of the curve. There are 2 methods also here. You either use a table, using a table to get the nature of the turning points. When you use a table, use the values of x, and together with the gradient function, that is dy dx. Then you represent that one using a diagram. Then we have where we can also use the second derivative. We have our second derivative as what I have done here. After we have done a second derivative here, you substitute now where the value of x is a third, which will give you -4, and then you substitute where the value of x is equal to -1, which is giving you +4. You understand? When you substitute, and then you get the second derivative after substituting the value of x from the turning points. When you get a point of a positive, it means that that point is minimum. When you get that value as a negative, it means the point is maximum. Then in part B, we are supposed to determine the equation of a tangent to the curve at x is equivalent to 1. So at x is equivalent to 1, we need to get the equation of a tangent to the curve. So start here at x is equal to P1. Already we have at x is equal to P1, we have those points. At x is equal to P1, the points where the curve will passes through x is equal to P1, the value of y is equivalent to 0. Because you take this one and you substitute in this equation here, the value of y is equal to 0. So we get the points where the curve passes. It passes through when x is equal to -1, the value of y is equivalent to the value of y is equivalent to 0. So to get the gradient now, we have our gradient function here. We have our gradient function here, whereby we say that the dy all over dx, which is our gradient function, this one is equivalent to P3x squared plus 2 of x then minus 1. That is our gradient. Dy dx is giving us our gradient function, but the value of x here is equivalent to 1. So if you substitute the value of x here, the value of x there is equivalent to 1. What is that gradient? So we have 3. Instead of having our x squared, the value of x here is 1, and here is a square, then plus, this is 2, the value of x is 1, then minus 1, and this one is giving us 4. So you get that gradient, the gradient is equivalent to 4. So we have 2 things here. We have the points where the curve passes, it is 1, 0. We have our gradient, we call it M1, which is equivalent to 4. Then you have another imaginary points, that is x and y. From our form to work, you will understand how do you get the equation of a line, change in y all over change in x. The change in y all over change in x will give you the gradient. So our gradient here is equivalent to 4. So an imaginary point of y minus. So there is y2 minus y1. So we have this y. The value of y is 0. So you subtract the 0 here. Change in y, change in x. Then you divide by. Here we have an imaginary of x. Then minus 1 x. we minus 1 here, and this one is giving us the gradient 4. And since there is no condition given here, you can leave your equation as, okay, you can simplify here, and then you get your equation as, you put this one over 1. Transformation, 1 times y is giving us y. And any number times 0, it remains 0, so we remain here with only y, which is equal to b. 4 times x is 4x minus 1 times 4 is giving us 4, and that one gives us the equation of attachment to the equation of attachment to the curve. Then Roman 2, the equation of a normal to the curve. From equation of a normal to the curve is like in form back to form 2 is like we are finding the equation when the lines are perpendicular. So when lines are perpendicular from form 2, you understand that gradient 1 times gradient 2 in that case is giving us -1. Since we have our gradient 1 here as 4, so we have this one as 4 times m2 gradient 2, which is giving us that. It's giving us -1. So our gradient m2 is equals to p -1 all over. We get this one is -1 all over 4. So we follow now the normal procedure of getting the equation of a line, whereby we have change in y coordinate, so our change in x coordinate, which is y minus 0, you divide by x minus 1 is equals to p. The gradient now we know the p4, it will now be -1 over 4 because that is an equation of a normal to the curve. The equation of a normal to the curve now, the gradient is equivalent to the 1 over 4. So transformation 1 times y is giving us 4y, 4 times y is 4y. Then we have any number multiplied by 0, it remains 0. This is equivalent to p1. So we have this -1 over 4. Normally a negative goes to the upper number. So our -1 times -1 times x is giving us -x. Negative and a negative is a positive. So we have this one, and 1 times 1, of course, this is equivalent to 1. And since when you look at this equation here, we have not been told to find the equation in whichever condition. We have not been given a condition here that you leave the equation in the form of y is equal to bmx plus c. So you either leave the equation of like this one here, or you can proceed and get the equation in the form of linear form, whereby y is equal to bmx plus c, such that we have y is equal to p. You divide it by 4, such that we have 1 all over 4 of x plus 1 all over 4. So in linear form, you will get the equation in this one. Otherwise, since there was no any other condition that you are supposed to leave the equation in this form, ukifika hapa bado uko sawa. Don't forget to subscribe my channel, watch and share.